Bienvenidos, indeed, and welcome UMGC learners from the CMIT-455 Section 6380 course for the Spring 2021 semester. This is the CCNP ENCOR version 8 course from the Cisco Networking Academy curriculum, and in this packet tracer tutorial video, we're going to be taking a look at Packet Tracer Activity 15.2.3, where we take a look at Cisco's proprietary Hot Standby Router Protocol, or HSRP. And so what you're going to learn in this video is all of the details about HSRP from a basic configuration perspective. We're going to compare and contrast it with the two other first hop routing protocols, or FHRPs, which are VRRP, the Virtual Router Redundancy Protocol, and GLBP, another Cisco proprietary protocol, the Gateway Load Balancing Protocol. Now, VRRP is non-proprietary. So if you had a Cisco router and a Juniper router, and both of those routers were going to be providing first hop redundancy, you would want to run VRRP between the two of them. Because again, that's an open standard, and there are some advantages to VRRP, but we are a Cisco course, and so we are focused on the Cisco technology, and again, specifically Hot Standby Router Protocol, HSRP, is what we're going to be talking about here. Now, there are two versions right out of the gate. There's two versions of HSRP. You've got version 1 and you've got version 2. Now, HSRP will work with IPv4 and it will work with IPv6. In this activity, we're only interested in the IPv4 information. Now, a step back, the HSRP versions. So HSRP version 2, as you would expect, is an expansion, an enhancement to version 1. Version 2 gives you 4,096 groups, as opposed to HSRPv1, which gave you from 0 to 255, so 256. The multicast address that HSRP version 1 uses is 224.0.0.2, and the multicast address that version 2 uses is 224.0.0.102. And if you wanted to talk about IPv6, IPv6's multicast address is FF02::66. And this is the address. I want you to think about EIGRP and OSPF and how those protocols communicate with each other. Well, HSRP uses these multicast addresses to perform its communication, and it's the sending and receiving of the hello packets in order to establish the HSRP group. Now, the virtual MAC address, which we're going to see, because again, we're talking about first hop redundancy. And what we really mean when we say first hop redundancy is it's the redundancy for your servers, for your PCs, your laptops. It's for the nodes on your network that are being used by individuals. And again, it could be for other things as well, but typically it's for nodes and PCs and servers and laptops, whatever the case may be, and they need some sort of first hop redundancy. Because if you think about it, if we look at the activity here for 15.2.3, if we're thinking about how PCA or PCB is going to get out of the local LAN, right? Either LAN 1 or LAN 2, to get up here to the web server. Well, let's take a step back and talk about how that communication actually takes place. So if I pull PCA up here, and I pull the command prompt up, and I try to ping the 209.165.200.226. So as soon as I hit enter, PCA is going to look to see, do I have a route to get to this network? Well, if it doesn't have a route, then PCA is going to look at its default gateway. In other words, I'm not connected to this network, is what PCA is going to say, so I'm going to send it to somebody who will know how to get to that network, who I'm told knows how to route packets. And that is going to be router 1 or router 3, depending on who PCA has, and actually let's step over here, who PCA has configured as its default gateway. Now you'll notice we can only have a single default gateway. So the question becomes, what happens if 192.168.1.1, which is going to be the, which is the physical IP here on router 1. If I come to router 1 and we go into privilege exec and I say show IP interface brief, you can see that our default gateway for PCA is the physical interface right here of router 1. And that's fine until the link here between router 1 and switch 1 gets cut, or the optic fails here on router 1, or the port on switch 1 fails. The line, maybe it's a line card in there that fails, right? If it was a modular type switch. So again, the point being that what happens when PCA can no longer reach the 192.168.1.1, then it has no avenue, no path to get out of the network, because its first hop, let me readjust that here, sorry about that, because its first hop has gone away, which is this default gateway. And the same is true of PCB. And if we take a look at PCB and look at its configuration, you can see that right now its default gateway is 192.168.1.3. And so that is what HSRP is all about. What it's going to allow us to do is it's going to allow us to create a virtual router. Now, I don't want you to think of this like VRF, because we're not carving up these routers here. We're going to do some software, some software configuration. I apologize there. We're going to be doing some software configuration that is going to make the LAN segments believe that we've got another router out here. And they're going to see an IP address, and more importantly, a MAC address that belongs to this virtual router. Now, router 1 could be the active router, and router 3 could be the standby. And whoever the active router is, they're the ones who own this virtual router, right? Now, again, remember, this is not a physical router. This is all being done in software. So whoever the active router is will be advertising the virtual router IP and MAC address. Because remember, this is so critical. When PCA goes to send something to the default gateway, typically, if not in the ARP cache, it would have to send out an ARP packet saying, with our ping command, if I pull that ping command back up, remember what we're saying with that ping command that we're going to run is, hey, I know the layer 3 address to get to this network. I'm typing it in, right? So here it is right here. But I don't know the layer 2 information that I need. So what's the MAC address for the next hop, that first hop redundancy that we're talking about, right? So I need to know the MAC address, but I don't want the MAC for the physical interface, because again, if that physical interface goes down, then I'm kind of helpless here. But if we've got this virtual router that router 1 is sort of fronting for, if you will, it's pretending, it's sending information out saying, hey, if you're looking for the virtual router and here's the MAC address for that virtual router, then come to me. And so what would happen is we try to get to that network, right? We don't know how to get to that network. So we ARP out and say, here's my default gateway IP. I need my MAC address for the default gateway in order to get this frame up to the router, up to router 1 or 3, whomever is the active router. So if I hit enter here, let's see what happens. And we may get a timeout on the first packet because, again, PCA is probably ARPing, right? Address resolution protocol. Hey, we know the layer 3 information, but I need that layer 2 information. And there it is. And so now I've got that layer 2 information for that default gateway. If I say ARP-A, There it is. Here's the physical address. That is the layer 2 MAC address for that physical interface. And we can confirm that, and just remember it ends in 9402. We come to router 1 and we say show int gig 01. And what do we see? There is our burned in address that ends in 9402. And that is exactly how PCA gets this traffic that it doesn't know a route for, that it doesn't know what to do with it because it's not connected to that network. It's going to send it to its default gateway. And so what we're going to do is we're going to configure HSRP to provide redundancy so that if this link goes down between router 1 and switch 1, the virtual router will swing over to router 3. And then PCA will know that I go this way to get to router 3, to get out of my local area network. And the same is true of PCB. So let's go ahead and dive in here. They give you some nice background. We're going to talk about a lot of the semantics behind the settings and the defaults, because this is one of the technologies that Cisco loves to set you up with default questions on. So be prepared. All right, so the first thing we're going to do is we're going to trace the path to the web server from PCA. Well, we were just on PCA, so let's recall that command and let's trace route over to trace RT for trace route. And let's go out to the web server that's out there on the internet. And what do we see? Well, there's my first hop, my default gateway, router 1's gig 01 interface. Then I go to the 10.112, which is going to be router 2. It's that transit segment address right up in here. And then I go out to the 10.100.102, which takes me out to the internet. And then I land at the web server. So you can clearly see the traffic for PCA is following this path out of the enterprise to get out to that network. So which devices are in the path from PCA to the web server? And it's easy to sort that out. We can see that we're going, and in fact, let me check that 10.112 real quick to make sure it's not sending me over to router 3 and they're playing a trick on us. No. So 10.112 is the gig 00 interface on router 2. So that is the accurate path for PCA. So the devices in the path are switch 1, router 2, and then the internet cloud, if you will. And then we hit that web server. So let's trace the path to the web server from PCB. So we'll pull PCB up here, and we know where PCB is going to go first. Its first hop is going to be router 3's gigabit, and I can't remember, it's going to be gigabit 0001 probably. So let's go ahead and say trace RT out to 209.165.200.226. Now you can see that the first hop we take here is the 192.168.1.3. And so we hit the router right here. Now they're asking us which devices are in the path from PCB to the web server. Well, again, we're going to go to router 3, and then we're going to go to the 10.112. So let's go take a look at that, the 10.112. And again, that's the gig 00 identifier for router 2. Then we're going to go to the 10.100.102, which is out in that internet cloud. And then we're going to go out to the 209.165. And so the path that that PCB takes goes this direction, right? And so we can see that they both are able to get out of the network by default, no problems there. And so the devices in the path are switch 3, router 2, and the internet, and then ultimately we get to the web server. So let's observe the network behavior when router 3 becomes unavailable. And so what they're asking us to do now is to click on the deletion tool, which is the little X, and we are going to delete the link between router 3 and switch 3. And it's telling us that the remove is locked. Let's see here if I... All right, so that's interesting. It's telling me that the removal feature is locked, but fear not, because what we can do is we can pull up router 3 and we can go ahead and we can shut down the interface, I'll say show IP interface brief. It's going to be the 192.168.3. So let's get into global config, int gig 00, and let's simply say shut. And you can see this link is now down. It's as if router 3 is sort of gone from the equation here. Now, if we get any quirky results, I'll shut these other two interfaces down, but I think that that is probably going to facilitate what we want to see. So we'll pull PCB back up, and now let's trace out. Now remember, the first hop default gateway for PCB is that interface we just shut down. So it says, open a command prompt to on PCB, execute the traceroute command to the web server as the destination, compare the current output with what we got before. It says, what are the results? Well, again, we can click the connections icon here. We don't have to do this step because the connection is still there, but everything is timing out. And the reason that it's timing out is because my default gateway for PCB is down. And this is what HSRP and VRRP and GLBP can resolve, because we can put a virtual, think of it as an advertisement for, hey, use this as your default gateway IP address, and whomever the active router is will be advertising not only the virtual IP for the HSRP group, but the MAC address. So think of it as a virtual MAC address that's going to be used. So let's come back over here to router 3 and let's go ahead and say no shut. We'll bring that interface back up and let's see. And then they want us to test that again. And we'll do that here in a second as the spanning tree sorts itself out here. And I don't know the port. We could put port fast on there, but not worth it. We'll wait and come back until it turns green while we move on here. So configure HSRP on the gig01 LAN interface of router 1. And so here are the configuration commands that we're being asked to configure. And this is, again, HSRP, very straightforward. So we're going to go into interface gigabit, we're going to go into interface gigabit Ethernet 01. Now remember, that is currently the interface with the physical IP on that interface of 192.168.1.1. And so what we're going to do is the first thing we're going to do, remember, by default, HSRP is going to use HSRP version 1, but we want some of the enhanced features. And so we would say standby version, and you can see if I do a question mark here, it's either 1 or 2. So I'm going to say standby version 2, and standby is the command that's used to configure HSRP. Now, here is where learners will typically trip up, and this is where a lot of confusion comes into play. We talk about the defaults. So the default version of HSRP, if I don't change it like I just did, is version 1. The group number, if I don't put the group number, and more importantly, what happens is learners forget to put the group number, the default group number will be 0. And again, this tends to cause some confusion. Now, typically, if we're working with multi-layer switches, what you would want to do is those HSRP group numbers would correspond to the VLANs for which the forwarding of traffic is being done, for which first hop redundancy is being provided. Again, make it easy for yourself if you have to go back and troubleshoot. Because if I come in here and say standby and do a question mark, you can now see that we have 0 as the default up to 4095. So 4,096 groups. If I come over here to router 3 and let's go into int and let's actually first say do show IP interface brief, and it is gig 00 for that. If I was to say standby and do a question mark, so we haven't changed it to HSRP version 2 yet. In fact, let me see if that's a packet tracer, because my belief is that what we should be seeing, and let's come over here to a real Cisco router real quickly, and let's get into privilege exec into global config. I'm just going to go into interface fast Ethernet 00.10, and I'm going to say standby. Yeah, so that's what I thought. So what you should see if you're running HSRP version 1, and think about it, it makes sense, right? If I'm running HSRPv1, it's not going to show me that I could create 0 to 4095. for my group numbers. It's going to show me what I can actually create. It's not until I say standby version 2 that if I then said standby and I do a question mark, now it changes to 4095. So what we're seeing is just sort of a little packet tracer, let's call it an undocumented feature, glitch here, right? Where even though we haven't set up, and again, it may be set up already for us. No, it's asking us to configure router 3 as the standby router. So it's not configured for us. But again, there's a little snafu here with packet tracer showing us that 0 through 4095 are available for group numbers. Remember, you have to use standby version 2, HSRP version 2, which expands the number of groups supported. Now, there are other enhancements in terms of the timers. And those are sort of the important enhancements, right? Not often are you going to see over 255 HSRP groups. I'm not saying that you won't, but it's not often. It's not a common occurrence that you would see something like that. All right, so let's drop back over here to router 1. So now I've got this standby. Now I've got 4,096 group numbers available to me, keeping in mind that the default group number, if I forget to put the group number in, and a lot of times learners will do that, and then the I don't want to call it an adjacency, the HSRP group formation with router 3 doesn't function because we're using different group numbers. And so we need to be aware of that, right? So I'm going to say standby 1 IP, and that's what they're asking us to do. So now we're configuring the virtual IP address. Now, the key with the group number is that that is going to be reflected in the MAC address. In fact, the last 4 hexadecimal characters that you're going to see, it's going to be Alpha Charlie, so AC, and that's kind of locked in, right? So for HSRP version 1, the values for the last 2 hextets after Alpha Charlie, AC, can be 00 through, if we have 255 possibilities, Fox, so FF. And those last 2 hextets, sorry about that, the last 2 hextets are sort of what you can key on to figure out what the standby group number is. And so this value is very, very important. And if you forget to put that value in, it's going to use group 0. So remember that. So here's the IP address that we are going to provide to all of our hosts on the LAN segments to have them use this IP for their default gateway. And this is commonly referred to as a VIP, a VIP, or a virtual IP. And so again, people will just say, oh, what's the VIP for HSRP on that, for that group? So it's 192.168.1.254. Now, you can see we're in the init state right now. So now, hello messages are being sent because this router is interested in forming an HSRP group with someone else on the same segment. And remember, if I clear the segment out here, remember that router 1 plugs in here to switch 1, router 3 plugs into switch 3. We have a trunk link here. Everybody's in VLAN 1 right now. So 192.168.1.1 and 192.168.1.3, which are the respectively the IP addresses on the physical interfaces for router 1 and router 3, those can see each other, right? Across this trunk link, they're in the same subnet, they're in the same broadcast domain, they're in the same VLAN, right? And so that's why we're using a different IP address. We cannot use, and think about it, it wouldn't make sense to use the same IP that's already assigned to a physical interface. That's what we're trying to avoid, is the IP on the physical interface being used and then that interface goes down for some reason. So we're going to put this virtual IP address out here, and let me kind of draw that out and I'll leave this up here from here on out. And that virtual IP is going to be 254. And it's going to have a MAC address associated, and the last 4 hextets Because remember, the MAC is typically, you can see it as hexadecimal characters. It's going to be Alpha Charlie 0, 1. Those will be the last 4 because it's group 1. If it was group 2, it'd be 0, 2. Group 3, 0, 3, so forth and so on until, we get to the hexadecimal characters. Like if I chose group 10, we would see A at the end. So that's my VIP, my virtual IP. This is going to be the virtual MAC address, which you will see on these switches. Because again, remember, we're at layer 2. That's where the MAC address is at layer 2. So let me go ahead and I'm going to leave that up there. Let's change back to control mode here. So the virtual IP is now configured, and you can see that it started speaking. So it's going through its state machine, right? Just kind of like OSPF and EIGRP do in terms of the protocol. They go to init and then, talk about OSPF, right? And then what do we see at the very end? From loading to full, right? And so that's kind of the process it's going through. It's trying to find other speakers who speak HSRP on that multicast MAC address of 224.0.0.102 because we're using version 2. If this was HSRPv1, it would be 224.0.0.2. But it's 102 for the last octet for HSRPv2. And then finally, it says, hey, I guess I'm the standby. And then it says, well, you know what? Nobody else is out there. So I'm going to transition from the standby to active mode. But we've got additional configuration we need to complete here because this is another default setting where they will try to trip you up, challenge you to make sure that you know the defaults. So priority values, just like we have the root bridge in spanning tree. There, it's the lower the priority, the more preferable that switch is for being the root bridge. Well, here with HSRP, it's the higher the priority value, the more desired it is that that router would become the active router, right? Now remember, you can have one active router, right? And we'll talk about it in the context of a single VLAN here, right? So we're using this VLAN or VLAN 1. And so for VLAN 1, we can only have one active HSRP node, router. The node is the router. And you can only have one standby node. Now, I could have, and this is the first question learners will ask, well, what if you had router 4 out here and that's plugged in, and say router 4 is connected in here. And then router 5 over here is plugged in, and then it's connected up here as well. Can they be in the HSRP group? Can you have more than 2 routers? You absolutely can. Now remember, at some point you might reach the point of diminishing return by having way more redundancy than is actually required. Because remember, if we set HSRP up here, PCA and PCB would need to have both router 1 and router 3 explode, spontaneously combust, go down, whatever the case may be, to not be able to get up here to router 2. And there's a pretty good chance that if one of these goes down, the other one is going to stay up, right? Unless you've got some sort of hardware issue, Cisco routers tend to run for years at a time without actually crashing, right? So 2 routers is typically good. Maybe you see 4, depending on the size of the environment. Again, it's all about the use case. But if you've got 30 or 40 office workers or 100 office workers, 2 routers is probably going to be more than enough to do what you need to do. And we'll talk about HSRP here in a little bit, which is the sort of creating multiple groups, multiple HSRP groups, so that you have router 1 be the active for some groups and router 3 be the active for some groups, to load balance, to share the load between these 2 routers. Because right now, what do we have? We have router 1 is going to be the active, router 3 is the standby. And so no traffic will be going to router 3 from PCB or PCA, because as soon as we reconfigure the PCs, so that their default gateway points to that virtual IP address. It's going to depend on who the active node is as to who they will be sending their traffic to. Because remember, the active node is the node that is going to be advertising that it owns that MAC address and that it owns that IP address. And so that's how the traffic is going to flow. So we want to pick our active speaker. Well, we do that via priority. The default priority is 100, right? The default priority is 100. So if I don't put anything right now, my priority is 100. So you might be asking, well, what if you configured router 3 and left the priority at 100? What's going to happen? Now, if I configure them both at the exact same time, and you'll notice I'm caveating what I'm saying here. If I configure these both at the same time, and I leave the priority to the default value, it's the highest IP address on that LAN segment. It's not the highest IP on the router. It's not like picking a loopback, a router ID in OSPF, where you don't manually configure it. It's going to go out and look for the highest IP loopback right out of the gate. If that's not there, it's going to look for the highest up interface IPv4 address. That's what it's going to look for. That's not what we're saying. With HSRP, it's on the interface on which I've configured HSRP. So the physical interface here has an IP of 192.168.1.1. Over here, it's 1.3. So all things being equal, these configured at the exact same time or before it moves from the standby to the active state, router 3 would be the active HSRP router in the group, and router 1 would be the standby, because the interface IP on the segment on which we're configuring HSRP is higher for router 3 than it is for router 1. And so we don't want to leave things to chance like that. So we're going to say standby, and here's where it gets important, because the group number has to match, or else if I left it off and I said standby, and you notice it's going to let you do that, right? I've always thought that it would be nice if they forced you to put the priority in. So like if I hit standby and you do the question mark, you'd have to, the group number in, you'd have to put the group number in, right? But they leave it to chance. So if I said standby priority 150 and I hit enter, what that command means is standby 0, priority 150, group number 0. So I wouldn't be applying the priority to group 1, which is what I want. Now, the higher priority, the better. If there's a tie, it's the highest IP address between the routers competing to become the active HSRP speaker. So now we've got that sorted out. So the last thing they're going to talk about down here is if it's desirable that the active router resume that role when it becomes available again, configure it to preempt the service of the standby router. Now, this preempt command is interesting, right? Because if I don't put the preempt command here on router 1, and I don't put it over here on router 3, neither will preempt the other. In fact, let's take a look at that. We're going to go into Cisco modeling labs right now, where we have much the same environment already set up here. So if I was to come to router 1, and router 1's connection to switch 1 is on gig 03. So if I was to go into interface gigabit Ethernet 03, and let's go ahead and get into global config gigabit Ethernet 03, and I'm going to use a different IP. We'll say 192.168.10, but we'll use the .1, and we'll make it a /24. If I was to say standby version 2 and then standby 1 IP 192.168.10.254 and leave it right there, right? Now, let's see if we can get some debugs here. So if I say debug, I think it's IP HSRP. Let's take a look here. No, debug HSRP. I'm trying to, oh, debug standby. Sorry, debug standby. Debug standby, and then it will say terse. So we want to see a whole bunch of stuff going on for HSRP. So I've got HSRP configured here on router 1. And right now, there's no preempt command. So let me come over here to router 3, and we'll jump on the console here. And I think what I need to do, actually, and I apologize, I forgot to face gigabit Ethernet 02, do show IP interface brief. I think it's shut down, that interface. And yes, it's administratively down. So I'm sorry, int gig 03. And we'll say no shut. So we're going to bring that interface up, and there we go. So now we're seeing these HSRP messages. And now HSRP, its state machine, you can see init, HSRP enabled. It's moved from the init state to the listen state. So it's listening to see, is anybody else out there? And the standby timer expired because it's not, it's basically, it's not going to be, or I'm sorry, the standby timer has expired, meaning that it's going to go ahead and continue to speak to try to find somebody. But take a look at what happened here. Ultimately, we end up from the standby state to the active state. And so here's where the debugs become very valuable, right? So we get all these debug messages showing us what's taking place. It was speaking and it put itself as the standby because it's trying to figure out, is somebody else the primary? And then ultimately, there's nobody else out there. So if I say show standby, here's the information we have right now. And you can see state is active. This is the active HSRP speaker for group 1. You can see there's my virtual IP address. And so here's the active virtual MAC address, right? And you can see, remember, for version 2, it's not going to end in Alpha Charlie like we were talking about earlier, right? That was for version 1. In version 2, the MAC address is 0 Charlie 9 Fox, and then, so it's fox.fox. So f.f 0, I'm sorry, 001 at the end, right? And so that is what we're going to be seeing for that virtual MAC address because we flipped over to version 2. So if I come down here to the switch, and let's get on the switch, and let's say, show MAC address table. So do I see the HSRP version 2 MAC address? And I do. And so it's being advertised here, right? It's been learned on switch 1. This is a trunk link between switch 1 and switch 2. So if I come over to switch 2, let's see if it has a host that's trying to get to the virtual IP associated with that MAC address. Where is spanning tree going to be sending this? What's the MAC address table going to show for that virtual MAC? And it says forwarded out the port channel interface. So this way, across the port channel, right? I've got an LACP ether channel here. So forwarded across the port channel because this switch has that advertisement because it's getting it from router 1. And because again, router 1 is the active. So PCB, if I pull PCB up, and you can see PCB right now is just pinging the switch into which it's plugged. What if I was to say ping 192.168.10.254? Well, I've got reachability to get there. But the way that PCB is getting there, it's coming to switch 2, then to switch 1, and then up to router 1. Because router 1 has that virtual IP and MAC address configured. And so now let's come over to router 3. And remember, we don't have the preempt command configured right now on router 1, and we're not going to configure it over here on router 3. So let's go ahead and let's go into, first let's figure out the interface that goes into the switch 2. So it is gig 03, just on the same as both sides. So let's go ahead and go into interface gigabit Ethernet 03, and let's go ahead and say IP address 192.168.10.3. So we'll keep the last octet the same as the activity. And I'll remember to say no shut. And let's say standby version 2. Now remember, We're now using version 2. Let's put in the standby IP address of 10.254. The standby IP is the same on both, right? The standby IP is set to the same on both because remember, it's the virtual IP. And so, and what did we just do there? Do you see the mistake I just made? Talking about the mistake learners make, what was the mistake I just made? You'll notice we don't see any HSRP activity here, right? So let's say debug standby terse. And take a look. We're getting this duplicate. And again, this is what I like to call the fortuitous failure. So it group what? Group 0. And I wish I could tell you I did that on purpose. I didn't. I'm just typing the stuff out, talking, forgot to put the group number in. So the default group number is 0. It transitions to active, and what do we get? We're getting this syslog message saying we have a duplicate address because they're not in the same group. That's the problem. And so that MAC address, which is the real MAC for group 1, is complaining that, hey, group 0, you're trying to use the same address that I'm trying to use. And since we're not in the same group, this is a problem. So take a look. So now it's kind of going crazy here with the duplicate ARP entry detected, right? So what do we need to fix that? Well, let's get back into global config. Let's get back into gigabit Ethernet 03. And let's say no standby IP 192.168.10.254. Now that's going to solve our in the short term solves our problem, but we need to get the right information in there. So standby 1, and let me double check that. I'm pretty sure I used 1 over here. Yeah, group 1. Okay, just double checking to make sure. So standby 1 IP 192.168.10.254. So now these guys are like, oh, okay, I see how this works. And so take a look here at what happens. So added to the hash table, group 1 disabled, from disabled to listen, and then we're going to come down here, and where are we at? We should see, right, so it's put itself in the backup, and it's speaking, and it's gone into the standby mode, and then ultimately it'll go from speak to standby, and then that's where it'll sit, because we know right now, did we set a priority on router 1? We didn't, right? So what I told you before, I want you to ask yourself, right? And you can see here, group 1 on this router, HSRP state change, went from speak to standby. So, but the priority's the same, right? The priority's 100. So what I told you before about the higher IP, how come that didn't happen? How come when I say show standby brief, how come the state of this router is standby? And the active has a lower IP address. And the reason for that is because we haven't told either router, hey, preempt, right? Take over. And they call it, and you might see it here with the debugs on, it's called a coup, C-O-U-P, like a coup attempt, like you're going to overthrow a government. So the preempt is enabling a coup to take place that should have taken place. But since we're not preempting on router 3 and we're not preempting on router 1, then what happens? Router 3 comes up and says, yeah, I'm the standby because router 1 is already the active. It doesn't matter that it doesn't have it doesn't matter that router 3 has a higher IP on the interface. The state machine already finished the election of the active on router 1, and there's no preempt statement. So let's see what happens if we do this. Let's go back into global config, int gigabit Ethernet 03, and let's say standby. Let's remember our group number, and let's say preempt. So is this going to force an election right now? Because the IP address is higher on this interface than it is on the other, on router 1. It's higher on router 3's interface than it is on router 1. And you can see that we kind of missed the boat on that. So I've got the preempt statement in there, but we're debugging, we're not seeing anything. Show standby brief, which is a great command. And you can see that is the active. And so until something happens, and you can also see we've got the priority number, right? There's your priority number. And we can see here the P now shows up configured to preempt. If I come back up here to the show standby brief, where's the P? It's not there, right? So let's do this. Let's come over to router 1. And these are always good activities to mess around with in packet tracers. Let's come into global config. Let's go into Gigabit Ethernet 03. I'm going to say, sorry, not IP. I'm going to say standby 1 priority. And again, priority values can range from 0 to 255. So I'm going to say 255. Now remember, we still don't have the preempt statement, right, on router 1. So I want you to watch what happens if that interface goes down. Now remember, we're debugging on both router 1 and router 3. And so here we are on router 3, and you can see that router 3 very quickly went from standby to active. So router 3 is now the active router. So I say show standby brief. Preemption is enabled here. Priority is still 100, and on the other side is 255, but that's okay because it went down. So the hello packets were no longer being received. So now let's come on to switch 2. Let's rerun that show MAC address table command. And now where does switch 2 say to send traffic? Send frames, layer 2 frames with this MAC address. It's no longer out the port channel interface. It's straight up to router 3 because the virtual IP and the virtual MAC, when router 1's interface on the LAN went down, those swung over to router 3. So router 3 is now the active node. Router 3 shows standby is now the owner. Sorry, not on the switch. Router 3 is now the owner of that information. And you can see right here, state is active. All right, well, let's do this. Router 1's got a higher priority. We bring the technician in. Your junior guy runs in and says, oh, somebody unplugged the cable. We plug the cable back in. So we'll simulate that by saying no shut. And let's see what happens. And here we go. And the HSRP state machine, right? It went to init, and then it transitioned to listen. And now it's in the backup state. Now it's in the speaking state, right? Where it's sending its hello packets out onto the LAN segment. And let's see what happens here. Well, this is interesting, isn't it? Because if I say show standby, and you can see what's the priority on that interface? It's the highest it could possibly be. However, what's the state of router 1 right now? It's still standby, or I should say it's now standby. Why didn't router 1, with the highest priority valuable possible configured on that LAN facing interface, gig 03, why did it not take back over? Why does it think that the active router is still router 3 with a priority of 100 of all things? And you guessed it. It's because we never told router 1 that if you, for whatever reason, no longer are active, that you can preempt, do a coup on whoever is the active HSRP router for group 1. And so router 1 will come back up, and router 1 will go right into the standby mode. So we say show standby brief, and it is not set to preempt. So it's going to sit in the standby mode. Interesting how that happens, isn't it? So let's get into global config and let's fix this. We'll go into global config int gig 03, and we'll say standby, and we need to make sure we get this group number correct, preempt, right? Standby 1 preempt. And now take a look at what's happening. You can see here, it is now taken over as the active node with the higher priority value. And 192 router 3 is now the standby for group 1. So let's go to end and let's say show standby brief. And there we go. State of the local router is active. preemption is configured. The priority is 255. So the next time that int gig03 goes down, right? And then router 3 is going to end up taking over as the active HSRP speaker. And you can see that over here. And it's going to happen pretty quickly. And these packets, right? So HSRP packets every 3 seconds, 3 packets missed, then it's going to roll over, right? It's going to flip over. And what's happening here is we're actually shutting the interface down so it's completely unreachable. And the 3 seconds is HSRPv1. I believe it's the same in v2. I'd have to double check that in terms of the sending and receiving. So again, we bring the interface back up here with HSRP and watch what happens. We're going to transition immediately to, well, I say immediately, very quickly to the active state, right? And so now, show standby brief, it's in the active state because we have preemption configured. And so that's what preemption is doing. And again, I apologize for the segue there, but preemption can be tricky, right? As to where you set it, why you would set it. Okay, so what will the HSRP priority of router 3 be when it's added to HSRP group 1? Well, by default, it's 100, so that value is going to be 100. So let's come over here to router 3, and let's figure out the final steps here. Let's get into privilege exec, into global config, and it just wants us to configure the same steps as 1B and 1C above, which I think, yep, it's just the version and the IP. And again, I don't need, and you'll see what happens here when they don't have you put the preempt on here. So let's go ahead and get into do show IP interface brief. Let's see which interface we're dealing with. And it's going to be gig00. And we're going to go ahead and say standby version 2 and then standby 1, right? Got to get that group number correct. 192.168.1.254. And you can see here we get this HSRP state change syslog message, right? Informational, telling us that it's gone to the init state. And now we've got hello packets going back and forth so that they can discover each other on that multicast address for HSRPv2, 224.0.0.102. And we went from speak to standby. Do show standby brief. And here you go. And you can see, is preemption configured? And the answer is no. It's just the standby, right? So let's do this. They didn't want us to configure anything else other than 1B and 1C. So we did the show standby command on router 3. If we come over to router 1 and go into privilege exec and say show standby, you can see state is active. And there is the version 2 MAC address. And I apologize. I think I'd written the version 1 MAC up here for that Alpha Charlie. But for version 2, remember, group number 1, there it is. We can go up to 4095, right? So be aware of that. And obviously, you would see different values in here. But for group 1, that's all you're going to see, right? V2 is what we're using. And that is that virtual MAC address. You can see who the standby router is. You can see what our priority is configured to. You can see the group name, right? Which is really just sort of on gig01 group 1, right? And it shows you the interface here, gig01. So that's our HSRP group name. We did the show standby command. Let's take a look at, do the full command here. Do show standby. And you can see we're only at 50% because we've got some things we still need to do here. So, and I like the way they're kind of setting this up, and this is, so it says, using the output shown above, answer the following questions. Which router is the active router? Well, it's router 1. What's the MAC address for the virtual IP? Well, we saw that right here, the quad zeros, 0 Charlie 9 Fox, Fox 001. What's the IP address and priority of the standby router? Well, the IP is 192.168.1.3, and there's my priority. It's pretty straightforward, right? When we take a look at this information. So you show standby brief, and we took a look at that output actually already. So now we're going to change the default gateways on the PCA and it says PCC, switch 1 and switch 3. So that's a typo right there. It's either a typo here where it says PCB, or it's a typo here where it says PCC, but you get the idea. These 4 nodes right here, we're going to change the default gateway. So let's come on to PCA, and let's come into the configuration here and say 192.168.254. And they throw us 10 percentage points for that, right? And let's go ahead now and see, can I trace route out here? And I can, and you can see we're still going through router 1 because router 1's the primary. Let's come on to the switch. Now, if you're scratching your head saying, well, wait a second, how do I configure the default gateway on the switch? Remember the command IP default gateway. This is not to route traffic, transit traffic. This is for control plane traffic. Like when I'm SSHing from the switch or to the switch, or I'm pinging from the switch. So IP default gateway 192.168.1.254. And then we would run the same command over here on switch number 3. And you can see we're getting thrown 10 points every time we do this. And we'll come over here. We'll go into privilege exec, global config, IP default gateway 192.168.1.254. All right. So which address should you use? Well, we should use the virtual IP address. Verify the new settings, issue a ping from PCA and PCC. So I'm assuming that the typo's here. It should be PCC. To the web server. Are the pings successful? Let's give it a try. We can trace out there. So pretty good chance that if I can trace route all the way out there, then I'm going to be able to ping all the way out there. Let's take a look at PC. It's listed as B, but we'll treat it as C. And can I trace route out to the web server? Let's see if I can get out there right now. And I can. And you'll notice that this is interesting. What is it showing? Let me ask you, why is it showing that? Why is it going to router 3 still? Well, let's pull up the config. That's the default gateway. So that's why it was going to router 3. So let's change this to 254. Let's come over here, jump into the command prompt, and let's rerun that command. And now, where do we go? And yes, I did do that on purpose, by the way, so that we could see that before I change it, it's going to router 3. It's going to the hard-coded IP address that we have in there for the default gateway value, which is the physical interface of router 3. I change it to the virtual IP that's owned by router 1, along with the virtual MAC address with the quad zeros, dot 0 Charlie 9 Fox dot Fox 001. And now that's where that traffic is going. If I come here onto switch 3 and say do show MAC address table, where is... There it is right there. And you see we're using VLAN 1. And what's it say? It says to go out gig 01, which is the link right here between switch 1 and switch 3. So PCB, when its traffic at layer 2 is trying to make its way to the default gateway, will come to switch 3. It no longer goes up here because that's no longer the MAC and IP address. It's going to come over to switch 1, and then it's going to go up to router 1. And so we can see that information there. Verify the new settings. We issued the pings. Are they successful? Absolutely. Observe HSRP operations. So open a command prompt on PCB. So now they're calling it PCB. All right, so stick with us and enter the command trace route. Well, we already did that, right? We already did that trace out to the 226. And it says, does the path differ from the path used before HSRP was configured? And the answer is yes, and we saw that. Let's break the link to router 1. So select the delete tool. My guess is that if I select the delete tool and I try, okay, good, so it's working there. All right, so select the delete tool, and we got rid of the connection between router 1 and switch 1. Immediately return to PCB. Oops, sorry, I didn't want to remove PCB there. Whoops, nope, don't want to remove PCB. And let's jump back on the PCB, and let's rerun this command. And now look where it goes. It immediately goes up to router 3 because router 3 would have assumed the role as the default gateway. And if we take a look at and you can see it transition from standby to active. And so we got some OSPF messages there. But if I was to say show run and we took a look at that interface, you can see gig00 is now going to be advertising the virtual IP and MAC address because it has taken over from router 1 because that link is gone. And you can see we had a little timeout action there, but that's okay. If I reran it, we should rip right through all the way out. Whoops, sorry, all the way out to the internet. So now on switch 3, let's say show MAC address table. Now where is it telling me to go? Is it out gig01 to get over to switch 1? No, it's gig02, which is going to take me right up here to router 3, because router 3 is now the active speaker. If I'm on router 3 and I say show standby, we are now the active HSRP speaker. If I say show standby brief, the standby is unknown. I no longer have reachability. Remember, they may be able to speak OSPF here. They're directly connected right here, but they are not running HSRP on this link, nor would they run HSRP on that link. The HSRP packets are LAN packets, right? Those are packets that are going to be floating across the local area network on which these routers are serving as first hops, as default gateways for the PCs that are here. And so from an HSRP perspective, router 3 doesn't even see router 1 anymore. It's gone as far as it knows because the way that it sees it is through the hello packets. All right, so verify the new settings, issue a ping from both PCA, and now we're calling it PCC again, I'm sorry, we're back down here. I skipped a step. Does the path differ? It does. We selected the delete tool. How does the trace differ? Everything's going through router 3 now. In fact, if I come over to PCA and we try to trace out, we're going to go over to the 192.168.1.3, which is the physical interface here, because this router is the active HSRP speaker, right? So you see how that happens there. So HSRP undergoes the process to determine which router should take over when the active router becomes unavailable. And that's what happens. So now let's restore the link. All right, so we'll come down to the connections here. We'll grab a straight through cable and we're going to connect it. And to be honest with you, I can't remember what the connection table had for this. So we'll say it's all VLAN 1. So we'll just say gig 01 or 02 to 01. And if this is gig 02, let's go and do int gig 02 and let's say spanning tree, port fast. There we go, to get rid of the orange dot, waiting 45 seconds. And reconnect switch 1, router 1 to switch 1. Execute the trace from PCB to the web server. You may need to repeat the trace to see the full path. So now let's see where the trace goes. And you can see it goes over here to router 3. So if I come to router 1, what happened here? Why is it in the standby state? Well, let's take a look at the configuration. And what command do you not see on the HSRP configured interface here? What command is missing? And again, we just saw this earlier. Priority value is higher. Okay, hey, that's great. However, show standby. I'm the standby. I should be the primary, but or the active, but I'm the standby. Because why? Show standby brief. Where's the P for preempt? The P for preempt is not there. So if the preempt command was not configured on router 1, would the results have been the same? Or if the preempt command was not configured for the HSRP group, and I think, did we even skip that? I may have skipped that. I thought we had the preempt command on there and we didn't. So again, fortuitous failure, int gig 01, do show run. And did I put that on? I thought I had put that on there. So standby 1 preempt. Now with the preemption on there, you can see we've gone from standby to active because we should have been the active. And so if we are the active, the trace route is now going to go through router 1. Router 1's the active router. Now we're showing 90% here. And I'm wondering if it might have been an order of operations when I overlooked. And sure, yeah, there it is. Look, preempt, right? Standby 1, preempt. It says incorrect. And even when I added it after the fact, it did not like that. So here's typically what you can do is we're going to come on to router 1 here, and we're going to exit out. I'm going to say default, and let's take a look at that interface first. Do show run, and we want to see gig 01. So there is gig 01 with all its commands. So let's see if the default interface command is supported here for Gigabit Ethernet 01. Okay, good. So nothing should be on Gigabit Ethernet 01 at this point. So I'm going to come in here. I'm going to say IP address 192.168.1.1. We'll make it a /24. Whoops. I'm going to say standby version 2. I'm going to say standby 1 IP 192.168.1.254. And we're going to say standby 1 priority 150. And I'm going to say standby 1 preempt. And yeah, it still does not like the fact. It's still not going to give us those points. So the final thing that you could do is you could reload the router. And you'll notice when I hit reload, the completion percentage is at 70, right? Because it's kind of taking those points away. And the hope is when the router comes back up, that the preempt command is going to do what we in there, and take a look at that. Completion percentage 100, right? Remember, Packet Tracer is software. Sometimes things like that are going to happen. All right, well, that is going to do it for our tutorial here on Packet Tracer Activity 15.2.3, where we took an in-depth look at some of the basic configuration around HSRP, how to get HSRP set up, how to change from version 1 to version 2. We talked about the MAC addresses. You saw how the virtual MAC and IP will swing between the routers. We used Cisco modeling labs, which we're going to be using to do some more advanced HSRP configuration, where we're going to configure some groups, maybe do some tracking of interfaces and the timer values. Again, with version 2, that's really where you have an advantage over version 1, and that is in the timer values that you can use if you're trying to get like sub-second type failover. All right, well, that does it for this activity. Thank you guys so much for watching. Hopefully this has helped you out with your HSRP understanding, and I hope to see you in the next video.